Hello everyone. First and foremost, I'd like to thank Department of Physics and Dr. C.P. Sir of Namche Government College and Sikkim University for providing me such a platform to make a video for partial fulfillment on BSc Honours on Physics at 5th semester June to December 2020. My name is Nunam Suba and my roll number is 18NS0013 and this topic is carrying 25 marks instead of 25 practical examination for our examination. So my topic is Wein bridge oscillator. Wein bridge oscillator is a type of oscillator that produces sine wave. Sine wave means this kind of wave. It produces a large range of frequencies. Wein bridge oscillator is based on bridge circuit and is originally developed by Max Wein in 1891 for the measurement of impedance. Impedance means it is a measure of total opposition to current flow in alternating current circuit made up of two components, ohmic resistance and reactance, and it is represented in complex notation as Z is equals to R plus Ix, where R means ohmic resistance and R means reactance. So now let's proceed to Wein bridge circuit diagram. To understand its circuit diagram, first we have to draw two common emitter transistors. And they are connected to common emitter mode. This is grounded. And these both transistors are connected in voltage divider biasing arrangement. Your capacitor is connected to a capacitor. This is also grounded. And these are connected to a supply called VCC. Now, from this first circuit, coupling capacitor is formed by connecting to the base of the second circuit like this. Again coupling capacitor is formed from the second circuit for the feedback arrangement. It's connected to output terminal, and this output terminal is also grounded, which is called as V0, the output. So the circuit diagram is of bridge, so we have to make a bridge circuit. So let's make a bridge circuit. Capacitor. Connected to capacitor, and this is also connected to coupling capacitor. This bridge circuit is also grounded. From this point is connected to the output terminal. And this point is connected to the first circuit. So this is a diagram of Wein bridge circuit diagram. Let's name it R1, C1, R2, C2, R3, R4, C3, R5, R6, R7, R8, R9, R10, R11, C4, C5, C6. So we have 11 resistors and 6 capacitors. These R1, C1, R2, C2, R3, R4 are used for stabilizing purpose. It is a bridge circuit which is used for stabilizing purpose. And R1, C1, R2, C2 are lead, lag, network, and R3 and R4 are voltage dividers. And so the phase shift is 180 degree. But according to Bark-Hazen criteria, the phase shift must be 360 degree. So the phase shift difference between input and output must be 360 degree. So this second circuit produces phase shift of 180 degree, which is also called as inverter circuit. Why? Because the oscillation produced from this circuit is inverted here, and this circuit is used as a production for oscillation and also is used as amplifier. And it is input terminal, and this is output terminal. And most important thing is this R4 resistance is replaced by tungsten lamp. This R4 resistance tungsten lamp. So this is a complete figure of Wein bridge circuit diagram. So now we will proceed to mathematical expression. Mathematical expression. As we know that the bridge circuit consists of 4 resistors R1, R2, R3, R4 and 2 capacitors C1 and C2. Let me show you the figure. This is R1, C1, R2, C2, R3, R4 and this is grounded. As this point is connected to output terminal, so it will be V0. So we know that for balanced circuit, R3 by R4 equals to, name it as A, B and C. So R3 by R4 equals to resistance across AB by resistance across BC. We know that resistance of a capacitor is equals to 1 by iota omega C. So for this C1, resistance of C1 equals to 1 by iota omega C1, and similarly for resistance of capacitor C2 equals to 1 by iota omega C square. Now, as AB is in series, so the formula we know is R3 by R4 equals to R1 plus XC1. This is the formula for series circuit. So now BC is in parallel, so the formula is R2 XC2 by R2 plus XC2. Now we will substitute this value here. R3 by R4 equals to R1 plus this value 1 by iota omega C1 by R2 into 1 by this value iota omega C2 by R2 plus 1 by iota omega C2. Again, R3 by R4 equals to, take this in bracket, then we will take this portion to numerator into form like R1 omega C1 R2 plus 1 by iota omega C2 divided by R2 by 1 iota omega C2. We got R3 by R4 equals to R1 plus 1 by iota omega C1 into R2 plus 1 by iota omega C2 by R2 by iota omega C2. This is what we got. Now in order to make it simple, suppose R1 equals to R2 equals to R and C1 equals to C2 equals to C, then R3 by R4 equals to this portion will be R plus 1 by iota omega C, R plus 1 by iota omega C by R by iota omega C. This is what we got. Now R3 by R4 equals to, these are common, so it will be R plus 1 by iota omega C whole square by R by iota omega C. Now we will use the formula of A plus B whole square here. R3 by R4 equals to A square plus omega C square to A B by R plus omega C. Now we will multiply this term with this term, then it will form R3 by R4 equals to iota omega C by R square. Iota square means minus 1, so minus 1 by omega square C square. And if we multiply this term with this term, then this and this will cancel, and R will cancel, and it will come only 2. Now as this term is imaginary and this term is real, so by multiplying imaginary components with real components, it will form imaginary components. Now compare real components from both sides. R3 by R4 equals to, this is real components, 2. Therefore R3 equals to 2R4. Now compare here imaginary components is 0 equals to, and here it is omega c by r square minus 1 by omega square c square. Now this term will go here, then it will form 0 equals to r square minus 1 by omega square c square. R square equals to 1 by omega square c square. Squaring both sides, r equals to 1 by omega c. Now omega equals to 1 by r c. Omega means 2 pi f equals to 1 by r c. F equals to 1 by 2 pi r c. And this is the frequency of Wein bridge oscillator. Working, the oscillator are designed simple size is compressed and it has a stable frequency output. The maximum frequency output is 1 megahertz. And this frequency is from phase shift oscillator. The total phase shift oscillator is from 360 degree or 0 degree. It is used to find unknown values of the component, and in most of the cases it is used in audio. Advantages of Wein bridge oscillator. Number 1, it is used to measure audio frequency. Number 2, Wein bridge oscillator designs long range of frequencies. Disadvantages of Wein bridge oscillator. Number 1, the circuit uses 2 transistors and large number of other components. Number 2, the maximum output frequency is limited because of amplitude and phase shift characteristic of the amplifier. So I would like to conclude by saying that Wein bridge oscillator is easy to understand in theory, but the practicality of the circuit can cause designer frustration. Insertion of a DC port in 3 critical areas of the circuit ensures operations and factory or user accessibility.